Good evening, everyone. Thank you again for joining us in the Magic Shine Dome for another of our lecture series. This is the fourth in the series, AI, the promise, the perils and the path forward. My name's Lish Fejer. Before we start, I'd like to acknowledge that we're on Ngunnawal country tonight, and I'd like to acknowledge and pay my respects to the traditional owners of this land, as well as the lands on which our online audience are joining us from tonight. As we share our own knowledge here tonight, the teaching and learning and research practices, we also pay respect to the knowledge embedded forever within the Aboriginal custodianship of this country. Now, anyone who's been along to this lecture series and joined us every 2 months, I have been conducting this, and tonight my face is some science communication. I just want to highlight, I'm quite red tonight because of science. I am wearing this as a little placard to say, get your skin checked. This is 53 years of enjoying sunshine in Australia. So I'm on the Fluorosil treatment. Has anyone else had this? The skin cancer treatment? It is amazing. Apparently we look 10 years younger when it's done. Anyway, but it's just for your science communication, it's basically a chemotherapy cream, and it's the Fluorosil, which is the chemoactive ingredient. It seeks out rapidly dividing, multiplying cells. And so cancer cells being thus, it goes and finds them and destroys them. And in the process, yeah, this is what it is, but it's remarkable. So this, just let this be for Science Week. I'm wearing this face for Science Week. And please get your skin checked, because skin cancer is a remarkable thing. They can only cut it out if they don't do this, and the longer you leave it, the more they have to cut out. So please, be a good Aussie and go get it checked out. Now tonight, I'm so delighted for our fourth in this series. I think if we've learnt anything, we've learnt that AI is going to impact every single aspect of our lives, and it's going to be used in places that we could never even begin to imagine. So tonight, AI and our food, agriculture, not just from the palate perspective and what we're eating, but everything, how farmers produce that, how agronomists manage the soil, the pests, everything to bring it to our plate, and even the markets to determine what crops should be grown depending on our tastes. And then the remarkable speakers that we have on a silver platter before you tonight are going to bring their knowledge of this field. We're going to be meeting second, Associate Professor Sigfredo Fuentes, who is not just about food on the ground here on Earth, but how we do it in space. But our first speaker tonight is Dr. Sarah Hartman. Now, Sarah is a postdoctoral fellow at Data 61 at CSIRO. She's looked at deep learning to develop an AI agronomist. What is an AI agronomist? What even is an agronomist? Well, Sarah comes with an engineering background, a love of agriculture and water and finding food to feed this planet, this rapidly growing planet. So can you please give a big warm welcome, whether you're online at home or here in the Shine Dome with us tonight, to Sarah.
Wow, thank you so much for that generous introduction, and what a joy it is to be with you here tonight. So my name is Dr. Sarah Hartman, and tonight I'm going to talk about feeding the world bite by bite, how AI is transforming agriculture. And as was already mentioned, this week is also National Science Week. So I'd like to begin by acknowledging our first scientists in Australia. And I'd like to acknowledge the land that we're coming to today, here, the Ngunnawal and Ngambri people, and pay my respects to their elders, past and present. Now, I want to start tonight, not with a satellite image or a fancy neural network, but with a paper sign at Woolies. You know the ones, those fresh market updates. Tomato supply has been impacted due to inclement weather. This small, simple sign is also a story about changing weather, about heavy rains and ex-tropical cyclone Alfred in Queensland, followed by unseasonably cool weather, as well as detection of a disease outbreak in Victoria and South Australia. So what can AI do in this situation? Stay tuned tonight, we're gonna find out. In my talk tonight, I wanna make the point that AI is not a silver bullet. But when responsibly designed and rooted in good data, it can become a powerful tool for transforming agriculture. So let's dig in. You are what you eat, and so is AI. Just like our own diets shape our health, the diet we feed AI, what it includes, what it omits, the ways in which it is biased, impact what we get out of our models. So when we train our models with rich, local, and timely data, that is what we can expect to see coming out of our models. Data is the foundation of AI then, but how good is our global agricultural data? To answer this question, I joined a team of scientists across the world to ask this question. Our goal was simple but urgent. Understand where the data gaps are, why they exist, and how we might overcome them. And what we find is we actually have a lot of data, right? We have government agencies actively collecting lots of data. We have data being collected by hand and automatically. We have data being collected by sensors, satellites, drones. But it can be poorly connected. It's not always available at the frequency we want, or at the spatial granularity that's relevant for decision making, or perhaps sometimes we don't have good annotation on how that data was collected, which makes use down the line a lot harder. These types of gaps are present across countries and across our three main types of agricultural data: aquaculture, livestock, and crops. So to give you a bit more of an example, thinking about crop production, at the global scale, we lack public, up-to-date, spatially explicit maps of where tomato is being grown and what we expect its current season yield to be. These types of gaps limit our ability to make informed decisions, such as the impact of a disease in tomato in one location. And what is more, they're actually not just technical. In fact, these gaps are due to 5 main reasons, and they span both social and technical, or socio-technical challenges. So solving them isn't just about creating tech, it's about our entire data ecosystem. So what do we have in this? So first we have our modernization of methods. This is where our AI comes in, but it also has really important data collection, such as crowdsourcing and citizen science. And it also includes in situ sensors. So think that sensor you put in the ground in your field way out there, that from over here you can get what that soil moisture is. And it even includes improving access to and affordability of electricity and internet in regional areas. Next, we have limited data accessibility and interoperability. So think about open data initiatives, filling these gaps in how we're collecting our data so we can use it down the line. Third is data ownership and privacy. So really important here is raising data privacy awareness. Fourth, institutional capacity. This is what it sounds like, raising the capacity of our institutions. And last but not least, data source fragmentation and effort duplication. So how do we move from data in silos to coordinated, standardized, responsibly shared data infrastructure? So an example of how these bundles could work, again, going back to our tomato example, is the integration of drones and satellites and citizen science apps to know on the sky and on the ground how our tomato production is evolving in season. But these are most powerful when they're combined with clear data sharing policies, open science platforms, and coordinated support from institutions. So these socio-technical bundles, in conclusion, are about not just building tech, but building that ecosystem. Great. So now that we kind of know what some of these gaps are, let's explore what AI can do when it has the right data and thoughtful design. In this next part, I'm going to walk you through 3 stories. One about understanding the past, one about seeing the future, and one about seeing the present, and then one about projecting into the future. So one powerful way that AI is transforming agriculture is through satellite imagery. The analysis of satellite imagery, we can see a field unfold day by day, season by season, and year by year, from hundreds to thousands of kilometers in space. But images alone aren't enough. AI steps in to interpret these imagery, to flag spots where fields might be going off course with their growing, to identify irrigation spots that might be drying up. And this is particularly powerful in places where on-the-ground data might be hard to get or is missing. And in fact, in many parts of the world today, we have satellite imagery publicly available dating back to the 1980s. And what is more, today, we are capturing hundreds of terabytes. That's hundreds of trillions of bytes of satellite imagery data a day. These digital memories can help us understand how agriculture is unfolding worldwide. So let's look at some examples. First, I want to take you back in time to a city called Zamora, which is nestled in central western Mexico. Once a water resource-rich region, primarily growing wheat, corn, and potato, the region has become the berry capital of Mexico. The berries grown here, predominantly in greenhouses such as this, are packaged and shipped in refrigerated containers all around the world. Zamora is the epicenter of an agricultural transformation, and one that has changed the way the local economy works, the way that natural resources are used, and much, much more. So back in 2021, as part of my PhD, I traveled to Zamora to understand this agricultural transition. I visited Conafresa headquarters, this faded sign where the country's national berry data come to be. And on a typical day, if you walk in there, there's about 2 to 3 staff juggling massive data collection challenges. Now, during our conversation, they told me something striking. They actually lacked historic data of how this incredibly important berry transition began. So they had no way to benchmark and understand this transition from the past all the way up until the present. And this is where AI enters the story. So using satellite imagery from the 1980s onwards and a machine learning algorithm called a support vector machine, I was able to train a model to identify greenhouse expansion over time. So in this example, the data that the AI were eating was publicly available satellite imagery that's widely available and just waiting to be used for specific applications. We were able to get value from the satellite imagery and to track this expansion over 30 years, seeing a time when no greenhouses existed in the region and tracked it all the way up until the present. So now Conafresa has these maps to improve national reporting, and this example shows how AI can be used to reclaim lost chapters of history when grounded in local partnership. Now, we are hopefully going to move to the present. Let's see if I can get this to work. There we are. Thank you. So let's move to the present. Okay, we're going to southern Ukraine, a land that is rich with fertile soil. It is a breadbasket of the world. Now, in this region, agricultural productivity doesn't just depend on irrigation, rainfall, and soil. It depends on whether the land has been recently shelled. These are the lands on the front lines of the ongoing war. And in this work, my team was interested in understanding how these regions respond to disruption. Could we track agricultural resilience, even in crisis, by using AI and satellite imagery? As we were going about this work, one event in particular stood out. In June 2023, the Kakhovka Dam was destroyed. Now, this was an act with devastating consequence. This region is entirely irrigation dependent, and the dam's destruction occurred at the peak of growing season. Suddenly, crops that were reliant on this irrigation water had nothing. To understand the impact this was having on agriculture, we looked to our AI. Our AI model, again, ate publicly available data, and in addition to this, we used some privately available data too for ground truthing to monitor crop health before and after the dam's destruction. We used unsupervised machine learning of satellite imagery, as well as decision trees, to track agricultural activity through the season and across years, identifying signs of impact on the crops. What emerged was a mosaic of loss and persistence. We were able to identify zones of collapse, but also zones of hope. And this kind of insight can be incredibly important for humanitarian assistance and demining post-conflict. And it's also incredibly important in places where on-the-ground data is limited or unsafe to collect. And now we're going to move into the future. This might be what you all came here to see tonight, which is my current research, called the Trusted AI Agronomist. Now, this is an AI-enabled crop growth model that is designed to help farmers and agronomists and anyone across the supply chain model and maximize crop growth amidst uncertainty. So in this model, we use a feed-forward neural network to emulate CSIRO's Agricultural Production Systems Simulator, which itself is a crop model that models complex dynamics of crop, soil, and climate interactions. So let me break that down for you. The AI agronomist model is eating simulated data of important determinants of crop health. Think irrigation, think nitrogen application, and it's learning from the Agricultural Production System Simulator what expected yield will be. Importantly, from this method, we can get uncertainty bands of crop growth, which in this video, that's gonna be, the crop growth is that dark blue, and then the lighter area around it is our area of uncertainty. Now, most farming decisions are made under uncertainty. So knowing the confidence around a prediction, not just the average, allows farmers to take into account that uncertainty when they are managing very tricky decisions on field. And it also helps build trust in the model by demonstrating where in the model there's higher confidence and where there's less. We're going to move on to the next slide in just a moment. I'm getting a warning sign. Let's see. So in the future, perhaps tech problems may never go away. But okay, so maybe I can find an AI to help solve that one. So let's imagine a farmer named Jo. She's a mixed crop grower with properties in southern Queensland and northern New South Wales. As the growing season is approaching, she has these two big, gnarly questions. Where across her properties should she plant the different crops that she's bought seed for? And what if the forecasted rains arrive? Or what if they don't? So with this AI agronomist, Jo can actually run different what-if scenarios of higher and lower rainfall and see how that's going to pan out in the season. She can compare these side by side, and she can take these insights with the confidence bands to make a decision that makes sense on her farm. So we're still at the early stages of developing this model. There's a lot that we're getting great feedback to do next. I want to highlight kind of a really special and important component of this project. I'm really ready for an AI to come and help me. Oops. Okay, very good. So what's special about this AI agronomist project? We're actually centering it in something called responsible application-driven AI, or RAD AI for short. Now, yes, the acronym is RAD, and no, we didn't just name it that because we think AI is cool, which we do. But it's RAD because it reminds us that responsible, application-driven AI is grounded in context and designed to match real-world need. So at its core, this framework is about co-design. In this case, what that means is co-designing with our agricultural stakeholders who would be the end users. So think agronomists, think farmers, think ag tech. And why is this important? Because when AI is designed with stakeholders, it reflects their needs, their priorities, it builds trust, and it becomes a tool that they can genuinely use. Through our early stage engagement, we're learning lots about what's exciting about AI, and even what to put into our interface that sits between the AI and that end person. Now, I'm really getting nervous with these next slides, so. Okay, now, we're still talking about the future here. So I also want to give this slide to what's coming up in the innovation pipeline. Across CSIRO, we've got a lot cooking in terms of sustainable agriculture. Here, I'm highlighting just two of our wonderful projects. So we have researchers who are training AI-powered robotic arms to gently move through the canopy with applications in orchards. The process starts with simulations where the AI is learning how to mimic human behavior. And in the future, the idea is to work with people to directly train tasks like pruning and picking so robots can be safely deployed in field. Now, on the right up here, I have Ag 2050. And Ag 2050 is about exploring the future of Australian agriculture. What could, should, and should farming systems look like in order to make them productive, resilient, and sustainable by 2050? And as part of this work, I've been looking at some of the emerging AI that has the potential to really transform agriculture. So data and analytics, what we've been talking about a lot tonight, and then weather and climate forecasting, which again is so incredibly important for the success of our crops. And last but not least, the recent evolution of generative AI chatbots. And can I go to, yeah, great, thanks. So up until now, I've painted a picture of what AI can do, but what can't or shouldn't it do? So to demonstrate this, let me show you something surprising. My team and I wanted to develop, we went to OpenAI's DALL-E to ask for an image of data and AI integrated into Australian field. And this is what it gave us. Oop. An idyllic picture of farm country, probably in North America. Yikes. Next slide, please. And it took multiple prompts. Dryland, eucalyptus, before the image started reflecting an Australian landscape. This is a visible example of bias in AI systems, of AI being what it eats, right? So DALL-E has been trained to see a specific version of agriculture. And then if that version enters our Australian decision support tools or other applications, we risk projecting that image into Australia. So if AI learns a North American-centric view of farming, it could miss really important components of the local. Dryland cropping, local indigenous land practices, locally relevant pests and diseases. Next slide. So to bring it all together, let's return to our tomatoes, my teaser. So what could AI do in this situation? Quite a bit if it's designed well. AI won't stop the cyclone, and sometimes it won't be enough to stop that shortage. But AI could help forecast weather impacts on crop development earlier in the season, simulate yield losses, provide early detection of diseases and pests, It could also help logistics providers reroute supplies before disruptions hit the supermarket. And if you just can't find tomatoes anywhere, it can help you come up with a tasty recipe alternative. But like all tools, how we design it matters. AI is only as good as its design. Co-designed, fueled by a healthy data diet, and always checked by human expertise. Next slide. See, I'm asking the human to do this for me. So AI is not a silver bullet, but when responsibly designed and rooted in good data, it can become a powerful tool for agricultural transformation. But there's one last thing. I want to emphasize you here in the room, you online, to get engaged. We are a part of this history, right? Ask questions of the tools you use. Share your data and insights, join co-design workshops, and together we can feed the world bite by bite. Thank you.
Thank you so much, Sarah. So fascinating, and no doubt lots of questions starting to float to the surface. So please, if you've got a question, write it down, and we'll get to them after we've heard our next speaker. And online, if you've got a question, please just, I think the QR code, have we got the QR code system? Or just type in the, there's a system, isn't there? There's a system. I'll give you my phone number and you can call it in. I was really interested, Sarah, in what you had to say about that bite by bite, and I think we all know now that it is what it eats. AI has to have good data, but I must admit, looking at that robot smelling the oranges, I thought of myself, and if it's mimicking human behaviour, that is me, sort of just wandering aimlessly around an orchard. But I think it's going to get there. And good luck mimicking human behaviour, because I think we're almost as unpredictable as kangaroos. But it will get there. Our next speaker tonight joins us from the University of Melbourne, Associate Professor Sigfredo Fuentes, Group Leader for Digital Agriculture, Food and Wine at the School of Agriculture and Food at the University of Melbourne. When I was researching a little bit about Sigfredo, I got thinking about farming and how this vast country, as you showed, Sarah, it has so much farming. I grew up on a farm, and I remember my dad having to combat the cockatoos on the sunflower crop by coming up with amazing innovation, which was a gun that just let off loud bangs every now and then. I don't know how he did it, but the cockatoos were managed for a while. But you look at the technology that we have got now available for agriculture, for farmers, and for businesses. But not just on the ground, because Sigfredo is also an investigator at the Plants for Space ARC, which is the Centre for Excellence looking at plants in space. As you could imagine, how do we create a menu for astronauts? So can you please give a big round of applause for Associate Professor Sigfredo Fuentes.
Okay, so I would like to thank the organizers for inviting me first, and I'm feeling really scared now. Because Sarah, I'm an agronomist, so I'm gonna be replaced in no time. So, but I knew about it probably 25 years ago, so I had to reinvent myself. And I'm gonna talk a little bit about the journey of reinventing yourself using AI, because we were discussing before with the drinks. So, are AI gonna replace jobs? And I will say, not really. They're going to replace you if you don't know AI. They're going to be replaced by somebody else that knows AI in your job. That's amazing. So I tried to get a title for this presentation, and I'm really jet-lagged because I came last Friday from Germany. I had a presentation there, and I talk about unleashing the power of AI in agriculture and food sciences. Now, that is a double meaning of unleashing, because actually, you need to contain it, and we're going to talk a little bit about how to. So I'm part of, I formed the Digital Agriculture, Food and Wine Group. So we are a really small group. The University of Melbourne is huge, but we are really small working in AI. So there are 3 postdocs, all female. Actually, I have 25, in 15 years, I have 25 PhD students graduated, 90% female. So I'm trying to encourage females to go into STEM education and into AI in agriculture and food. And I think we are preparing the next generation of scientists in these areas. I'm having problems now. Hold on, next. Okay, so probably you know this, this picture is from the Voyager 1 that was taken in February 14th in 1990. When Carl Sagan, the latest Carl Sagan, said, let's turn around the sensors and take a picture of the Earth while it's leaving the solar system. So if you think about this picture and the implications, if you concentrate in a small part of a solar ray, I don't know if you can see it, there is a pale blue dot, that is us, at 6.5 million kilometers of distance. And that was in 1990, and they thought that the Voyager 1 was leaving the solar system. Now we know that it's leaving it now. So we didn't know the size of the solar system at that time, and our knowledge was really limiting. We're knowing more and more now that the sun that gave power to the solar system is one of more than 100 or 200 billion stars in the Milky Way. And galaxies in the known universe is around, they say, between 100 and 400 billion galaxies. But now the latest figures from NASA is 1.3 trillion galaxies in the universe. So I don't know. I know, the only thing that I know is that I don't know anything. Okay? So let's continue, and I need to go with the mouse this time. Okay. So you know this picture as well. So it's the picture that it was taken from the moon. It's the blue marble. For those people, I talked with some people that they saw the moon landing direct on the television. I missed it for 4 years. Actually, I was born in the year that the last mission to the moon, Apollo 17. So I was born in that year. So there was 50 years, almost more than 50 years that a human has been on the moon. And I'm going to talk about the next mission that we have a project with them. It's Artemis 3 that is going in 2027 to the moon. So it's going to be the first time after 50-something years that a human is going to go back. So this is the blue marble. So it's the first picture. And this image actually started a lot of environmental movement in US and around the world, because basically put us on a planet that is really small. We are all together, and there is a lot of things that we need to preserve in this planet. So that is basically another one. This is a bigger picture. It's the sunrise or Earthrise from the moon. So the main thing that we are trying to tackle now, I don't need to talk to you about climate change. I usually talk to my students is if you don't believe in climate change, you need to go out more. So probably this audience, I don't need to talk about climate change, but there is a big problem in climate change or climate change related. One thing is agriculture historically is being more reactive than predictive, and Sarah really brilliantly explained how AI can help in that sense, how to predict more and simulate seasons and try to make management or decision-making according to those simulations and the season that is coming. So that is brilliant. AI can do a lot about that. But we still have a problem of food waste. So there are like around 25% of food waste in the farm, horticulture and agriculture in general. That food doesn't even get out of the gate for aesthetic reasons, for any other reasons that they don't pick it. 25% is lost in the farm, and you have a further 17% that is lost in retail, in the supermarkets and retail places. And I don't need to tell you what happens in your fridges. every month or every week. But the main thing is all this food waste is around 8 to 10 times more than the greenhouse emissions from the aeronautic industry. So every single plane that is flying around the world now produces less gas emissions than food waste. So it's 8 to 10 times more food waste. So what we can do from space, basically, I'm going to talk about the project that we have, the ARC Center of Excellence in Plans for Space, in more detail. But when you're in space, when you're thinking producing space agriculture on the moon and Mars, you need to be 0% waste and 100% recyclable, because there is no more resources. There is nothing coming from Earth. So that is unacceptable. A mission to Mars is 3 years round mission. So there is no resupplies. Okay, so you need to be sustainable, 100% sustainable. So that is basically the talk that I'm going to do today. So the Digital Agriculture, Food and Wine, we established it in 2017, and since then we've been working in artificial intelligence applications to agriculture, food, and many other aspects. We're working really closely developing algorithms and tools for biometrics for plants, humans, and animals to assess all that is measurable from humans, plants, and animals. We work a lot on digital sensory analysis, how you perceive the food, not only consciously that you put in paper, but what is your reaction from the autonomous nervous system, which is 90% of the response from food and beverages. So it's an untapped data. We develop a lot of computer apps. I'm going to talk about some that we developed 20 years ago and still working. And we work in AI in psychiatry. So when you do biometrics for humans to assess emotional response, face recognition, heart rate, blood pressure changes, just with video, we don't put sensors on people, body temperature changes, there is a big application, and I didn't know. I was doing these presentations one day, and then people from the medical department from Melbourne Uni said, can we use this to assess PTSD or trauma? Why not? Let's try it. So we won a grant in the IDEAS grant from $1.65 million to assess all these tools for psychiatry. And I was joking around that I have a PhD now as a psychiatrist. And it's really good because I have monthly meetings with him. So half an hour is for his project, half an hour is for me. So I keep it, you need to keep it sane. And we work on Plan for Space, which is our flagship project now. We're going to talk a little bit about that really quickly. I don't want to go excess in time. And we do a lot of projects in Australian defense, and I can talk about those. But yeah, so it's just for you to know that there is a lot of applications beyond agriculture, food, psychiatry. There is applications on defense. And don't worry, it's actually my creed is only working on defense, not in offense. So I'm not doing that. Okay. So since then, it's 2017, we have published more than 150 papers in peer-reviewed articles. And as I say, 90% of our graduates are female, which is a recognition of a kind. I always, females are really interested in their area. Males are really lazy. For some reason, the students that I have, the 10% that I have is brilliant, but mostly are, Anyways, so you can see the web page and you can see the news. It's updated very frequently, so you can see all the outputs and updates, all the presentations that we are doing around the world, like the 150 papers since 2017. We are not a paper mill. Actually, we collaborate with a lot of people from international universities and institutions, and we collaborate with NASA. So there is all the techniques or technologies that we developed, we put it on public so they can use it, and it's a synergic project. Digital Agriculture and Food and Beverages for Earth. I wrote a chapter, so I can send it to you if you want, so you can contact me. I talk about how to apply AI in agriculture. This presentation is going to be really very focused on viticulture and enology, wine science, because why not? It's really entertaining, but it can be transferable to any crops or any other. Actually, I was a little bit lazy because, as I say, I jet lagged, so I came from a conference in Geisenheim, which was the group of experts in viticulture and enology, so I was presenting all these for them. But yeah, you can transfer to any other group. So climate change, as I say, I don't need to talk to you about much, but there are droughts, frosts, heat waves, diseases, smoke taint involved, and compression of phenological stages that all the agricultural people here, they know about it, and they're struggling to deal with it. So I don't need to talk much. This is a tool that actually I developed 20 years ago, 25 years ago, and it was answering a question from growers. So before my PhD, I worked in Berg. Do you know where Berg is? Berg. That was my first work here in Australia when I migrated 25 years ago. And it was challenging, especially understanding the accent. And through the two-way, imagine. So I just turn it off sometimes. But one of the main questions from growers that they were applying technology at that time, 25 years ago, soil moisture sensors, they were saying, I want to know what is happening with my soil, waiting on nutrient patterns from the crops. And I said, well, there's a way we can visualize it, and that was my first digital tool to assess two-dimensional, three-dimensional soil wetting patterns. So this is real data, it's not model data. And it's applied, Centec, which is a company, probably you know it, is based in Adelaide. They distribute soil moisture sensors and nutrient sensors for 54 different countries. So it's really well known in agriculture around the world. And they acquired this program from me. And this is a post from last month, I think. And they're still using it. So I was like surprised, and I'm still waiting for the royalties. Anyways. I think I was a bad deal. I just sold it for nothing. Anyways, so we applied not only for digital sensors, so we use biological sensors. So we train dogs to detect pests and diseases in the field and crops. They have 98% accuracy. You know that they've been used for COVID detection, for mines, for money, drugs, and customs, etc. So we train them to detect pests and diseases, especially phylloxera, for example, that is really underground, 60 centimeters underground. They're still capable to detect it. They have 100 times more sensitive noses than humans, so they detect parts per trillion of compounds. And the main thing, the digital part is just putting sensors on a backpack of them, and then the sensors with AI is trained to detect their signal. So either they crouch, they scratch, or they sit, and the AI with accelerometers, you can put even a phone to tap into their sensors, and it can detect the signal for a specific disease that you want to monitor, and it can map it because you use the GPS from the devices, and you can map, for example, phylloxera infestation in a vineyard. And we use it as well to detect if they're happy or not, so basically their welfare as well. Which kind of dogs? That's the main question they ask me. Which kind of dogs? You can train any dog. Obviously, for field work, I wouldn't train a Chihuahua. Unless you put it in the back of a ute. But yeah, it's going to take you 10 times longer. So another app that I started developing in 2008 for forestry, actually, when I was working in forestry at UTS in Sydney. So basically asking a really big question, how to assess the architecture of trees, like gum trees that are really tall, leaf area index, that the only way to assess it in real data is getting every single leaf and scan it. So that is the real leaf area index for the tree, but obviously you're going to kill the tree. So then I developed a code to use the cameras from smartphones, and then you obtain different parameters from canopy architecture. And it came commercial as a BT Canopy app. It's called BT Canopy, but it can be applied to any tree, basically. It's called BT Canopy because Wine Australia gave us the money to develop it into an app, okay? But you can use it, actually, it's mostly used for apple trees in Washington, cherry trees in Japan, grapevines in France, Portugal, Germany, in Europe. And there was a recent review in 2021 that it says it's the most widely used wine app for canopy management, which is a recognition of a kind. I don't know these guys, I didn't pay them. That is really good. I use it for classes to basically convey to students really complex concepts, and they can use their phone, so they don't need instrumentation or anything. You just take a picture and they get all the data and they can map it. So now we're trying to do more interesting things, like we develop an electronic nose, so we are using it for food, traceability of foods, for authentication, if they've been, for example, adulterated. Honey, for example, is a big example. Avocado oil is super adulterated. So we had a paper, actually, we published last month. And we don't say brands, but in US, 40% of avocado oil is adulterated. So you can see the paper anyway. So we don't talk about brands, obviously, because we're going to get into troubles. But yeah, so you can use these sensor technologies and it's low cost. So that is the main thing about artificial intelligence. If it is not based in low cost technology, it doesn't make sense, okay? And the part of an integration that Sarah explained brilliantly is like how to integrate of this technology. So how many people they work in agriculture and they have the boom, or you have every year you have the Christmas toy. For example, one year, soil moisture sensors, they're all digital, telemetry and stuff like that. All the growers, let's buy soil moisture sensors, they get a software. Then our meteorological stations and stuff like that, another software. Safflower sensors in the plant, and another software. They end up with, I don't know how many programs and try to make sense of all the data. At the end, they just spend time accumulating data and they don't do anything. So I can't really tell you how many times I've been around the world in different farms, and I've seen all that technology in the shed accumulating rust and not being used, basically. So digital applications in food and beverages. So we do a lot of digital twins. So from all these digital technologies, we assess and we compare. We use it as inputs in artificial intelligence models, and we assess using obviously trained panels in sensory analysis and more sophisticated instrumentation that it costs like thousands of dollars. But with low cost, we try to achieve what those time-consuming and more expensive sensors can do. So in that sense, and I'm not going to explain much about that, but we've done digital twins already for different foods, beverages, and other produces. And we worked in the sense that it's really easy. You get really complex information that is your targets, and you use as inputs digital technology that try to replace, like electronic nodes, to use all the senses from your aroma profiles, electronic tongues, chemical fingerprinting, etc. And with machine learning and artificial intelligence, you can obtain meaningful data. We've been working with a lot of companies around the world, so this is just a few of them for you to know. And the next step is also we are trying to assess biometrics, not with contact sensors, so it's based on face recognition and trying to see, for example, not only emotion responses, but we assess eye tracking, heart rate changes, blood pressure changes, body temperature changes. Just this is with video. Facial expression, as I said before, head movements, which is really a really powerful signal, because if you like something, when you smell it, you usually approach. It's unconscious. And if you dislike something, you go back. It's a simple signal, but it's really powerful. And we use a lot of computer vision since EVA to try to assess quality of beverages. This is formability from beer, but you can do for sparkling wine, color. And that was a pseudo electronic nose that we developed for that one. So this, you can see the, okay. So at the top left for you, That is a robo beer, so we constructed in 2014 with Lego parts. Lego motors is really good for prototyping and cheap. That was the first robotic pourer for beer perception. But obviously now we are doing more sophisticated things, so the robotic arms are getting cheaper and cheaper. When we started in 2014, it was $65,000 for a 6-degree robotic arm. Now it's like around $8,000, $10,000. So it's getting cheaper and cheaper, as any technology. So the robotic pourer from the RoboBee, actually from Lego, it was really famous. So we published around 42 papers, peer-reviewed, just with that one, Lego, thanks Lego. But we've been featured in Science magazine, Forbes, and many different outlets in the internet and other ones. So what I'm trying to say with all this bubble is how to integrate the different technologies from the farm to the produce and from the consumer, and getting that information back to the grower. So that is breaking the reactive part of agriculture into more predictive, and trying to target the produces from growers to specific targets or specific markets, like Asian market, European market, Latin American market, which is different appreciations and different perceptions and different likings as well, especially for wine. So that's a perfect example. The last one, these digital applications for space farming and produce for food and beverages. So we received a really big project in 2023. So it's an Australian Research Council Center of Excellence. It's $35 million that they gave us to 5 different universities. The University of Adelaide is the lead, and I work at the University of Melbourne in the node. And basically it's to be in parallel with the missions from NASA, the Artemis mission, that is planning to go to the moon and do a settlement on the moon by 2030, and to Mars by 2040. So we are basically producing the plants that they're gonna be producing the food, beverages, not only beverages, but also pharmaceuticals, biomaterials for like bioplastics, for example, for repairing. It needs to be 100% sustainable, 100% recyclable, and 100% usable from the plant point of view. So there are different skills, obviously, for the Center of Excellence that you need to acquire or produce. And those are the skills for the different 5 universities around Australia. So in Melbourne is plant physiology and sensory science, and food structuring, so the food engineering part. And we have many different partners, 32 different partners. So these are different universities around the world that we work with them, such as UC Davis, Berkeley, Cambridge, Nottingham, etc. And there are space agencies. Like we work really closely with NASA. So in 2 weeks, I'm going to the Kennedy Space Center to visit our partners before the new budget. I'm not going to. So many of them, it's really challenging. So many of them, actually, the group reduced the budget from 75 million to 25 million. So there are going to be a few cuts. So luckily I'm visiting in August because it needs to be ratified in the Senate by the 1st of September. So then my colleagues said, oh, they are camps, we're going to have a big party. So I don't know if I'm staying or not. So that perfect timing in that sense. Obviously there are companies of vertical farming because there is a big interest in vertical farming, production of food and beverages in space, on the moon and Mars. It's going to be vertical farming. And many other different agencies, the Australian Space Agency is there, and other, so 32 different partners. So try to coordinate is a nightmare, but yeah, we're trying to do the most. So it's been a year and something from this project that has been ongoing. We have already 120 staff members in the 5 universities, a lot of postdocs, and many collaborations. So I'm just going to talk about, we've done a lot of simulations for beverage and food in space for pick and eat of veggies, which is the simplest model, to beer for space and wine for space. So this is the wine for space that actually we did it a month and a half ago. So this is really fresh data. So you're the second people actually that are looking at this data. So the first one was in Geisenheim last week. And we use NASA caps. So these are 3D printed NASA. They were designed by NASA for zero gravity or microgravity, so it doesn't spill in the International Space Station. And it's really critical for the space immersive environments that we simulate on Earth, that you need to be in chairs at 170 degrees reclined. So the legs needs to be up your heart. And then you simulate what happens in space. So what happens in space really is basically your aroma sensation decreases and your taste increases. So it's a kind of COVID effect. Okay, so everybody that goes to space, they had COVID before, or the symptoms. And we compare it with Earth. So this is basically a simulation. So you can see at the top, like normal environment. Let me see if I can run it. Okay, so that is the normal environment. So it's a 150 degree screen. It's like a mini IMAX. And there is the app that we developed in the tablet. So it's looking at the biometrics of the people that is tasting the different products. And I'm just gonna put the space one. And the space one is in the reclining chairs. And actually that is an actual view from the International Space Station, the windows from Earth. And we've done it for around 300 people, consumers and trained panels, and they all report that it's like being in space. It's like, wow. And if you see, for example, the person has earphones, so we recorded the sound from the International Space Station. And in the other one is sound of a pub or a restaurant or whatever. So it's immersive environment. I'm not going to talk about data, but this is a principal component analysis, but you can see really clearly that the space conditions separates all the wines from the Earth conditions. And in the space is basically following what we developed or what we found, that the aroma profiles decreases, so the aroma perception, and the taste increases. So it's basically ratifying what we did in previous papers as well. And obviously from the machine learning point of view, you need to ratify that the models are working fine. So correlations of 98 is really good for to assess different flavor and aroma profiles of different wines. I'm not going to talk about that. So if you're familiar with the receiver operating characteristics, the models are pretty good. And confusion metrics as well. So 97.8% accuracies from predicting basically with the electronic nose, the really low-cost sensors, what people perceive wines on Earth and space. So the next step is basically trying to replicate what happened in space. So we are doing clinostats. So this is a two-dimensional clinostat. So this is a company, I don't know if you know it, it's Rotofarm, it's based in Sydney. They're gonna start producing all these commercially next year, but we have 2 units from them to test all our plants that are gonna be plants for adjuncts for beer, or to just pick and eat for space. And we are doing 3D printing of food as well. So this is, we have a 3D printer that is better than NASA. Actually, it's the latest model. We always boost around it. But it can print up to 5 different compounds. So it can be protein, carbohydrate, an emulsifier, fat, etc. So we're trying to 3D print, for example, steaks or salmon, sushi, sashimi, whatever, depending on the like of astronauts. And from the plants that they're going to be produced in space. And cellular agriculture as well. It's not going to be like a tofu steak. It's going to be actual a steak. We can't really bring cows, but with cellular agriculture, it can be possible. And this is the concept at the end. So you have the plants. They're going to be AI agronomists. Thank you, Sarah. So I'm not going to be there. It's not going to be a Mark Watney taking care of the plants. Obviously, there is an interaction between this is in Mars, interaction between the astronauts with the plants, because there is a psychological component there, a well-being component, but it's going to be always autonomous. The extraction of the protein, carbohydrates, and stuff like that, it's going to be autonomous. The processing and the 3D printing of the specific food for the astronauts. Now, this is going to be all controlled by AI with cameras. So when you're taking, for example, a salmon sashimi, and then one of the astronauts makes a like as to beta, the next production for that astronaut is going to be less beta. Okay, that's the concept. Okay, so we have 7 years to do it. So, as you know, the project has been all over the news, not only at the university level, but we have a program in landline. So if you are interested, last year we were in landline. We were featured in the List magazine, the 100 top innovators in 2024. We had an article from The Guardian, 10 News, we've been featured as well. And the latest project that I want to talk about, this is my last bit. So we're involved in the Artemis 3 mission that is going to be launched in 2027. It was programmed by 2026, but it was postponed. So this mission is going to be 4 astronauts. 2, they're going to land on the moon. 2 other, they're going to orbiting. And they're going to conduct experiments for a week on the moon. One of those experiments is the leaf or lunar effect of agricultural flora. So they're going to grow plants on the moon. So 3 species, duckweed, Brassica rapa, and Arabidopsis, which are fast-grown plants. And it's going to be the first time that we're going to have actual data for AI modeling and digital twin, so of the behavior of plants on the moon, because we have no idea what is going to happen on the moon. So it's reduced gravity on the moon and a lot of cosmic rays. So there are a lot of stressors, we have no idea, and with that data, actually they're going to bring the plants to Earth, and Australia is going to analyze part of those tissues, genetically and physiologically. So next week, basically, as I say, I'm going to go to the Kennedy Space Center, and I'm promoting the Enos to be in that container. So the Enos that we produce from Melbourne Uni to assess all the physiology in real time while they're on the moon, the plants. So wish me luck. So I just leave you with this saying. Actually, it's one of Marilyn Monroe's ex-boyfriends. We choose to go to the moon and do other things, not because they are easy, but because they are hard. So that is my message from today. If anything that I can give you a message is don't go the easy way, go the hard way. I was lucky enough that I combined all my 3 passions is computer science since I was a kid. And I dropped my age with one of you guys because I say my first computer was a Sinclair. So figure. Computer science, astronomy, and plant sciences. So it's all together now. And we need to break stereotypes and cliches as well. Try to reinvent cliches. I'm trying to do it in my classes. So I say to all my students, think outside the planet, and the sky is no longer the limit. Thank you.
Lock the doors, because we're not letting these 2 go. I don't know about you, but from NASA has its own cups to an electronic nose to everything else in between. I know we have gone over time, but we couldn't stop you, Sigfredo. It was so wonderful. Have we got time for questions? I'm just looking for an Academy person. Have we 5 minutes for questions? And I think if the online audience is still with us, you've got to get in quick, because I think there might be a few here. If anyone has a question, can you please raise your hand and we will send a microphone to you.
Yes, I wanted to ask whether you've got built-in transparent and accessible protocols for food, microbial and chemical food hazards and health hazards installed into all your endeavours.
Now, I'm not going to be able to answer that. I'd love to. Where do I start? Sigfredo and Sarah, can you please come up here and who would you like that? I think we've lost the microphone, but you can be quickly thinking of your answer as you come up. Sigfredo, would you like to answer that one?
Can you hear me? Yes. So what was the question? So about the protocols of biology. Yeah, yep.
Microbial.
So I don't know if you know the HACCP programs. You know, they were invented by NASA, actually. for the Apollo missions. So they have really strict protocols. I'm talking about space. And that is why, for example, they didn't accept anything else but plants. So we can't really bring viruses, bacteria, or fungus, because they don't know what is going to happen with them. The mutation is really high. I imagine with cosmic rays, it's going to be out of control. The plants, the mutation is slower, and actually you can replace the plant with the original material if you have the tissues. That will be easier. But in that sense, for example, for space, that is a protocol, so none of them. The thing is, why are we talking about beer for space and fermentation? Because you need yeast, and we are not allowed. But we're going to carry anyway. So astronauts, they're going to have beer, they're going to have hair, they're going to bring the yeast. So even in the US, there is a beer. It's actually the brewer, they put the beer actually in the in the concoction. So yeah, and actually it tastes nice. I mean, if it is 4.5% alcohol, everything is dead. So it's just the flavor and aroma from the guy.
And I think most of us were going, ooh, we were doing that. Read the biometrics on this.
But I mean, if you're going to be 100% recyclable, so you need to get all the nutrients that you put in the plants from feces and urine. So.
Okay, delicious. Next question.
Is that me?
It's not going to be pleasant.
Good evening. Thanks, Lish. The Vidi Canopy app, I assume it did use the data and information that came from the late Dr. Richard Smart for that.
Yeah, actually, I was a really good friend of Richard. So I remember the random calls from Richard every month talking about AI. And Richard was a character, actually. So explain to me what AI thinks, or whatever. It was really funny. Actually, yeah, so it's based on, so if you know about the leaf array index, it's based on the quadrat method that he developed. So yeah, it's a really good question. It brings me memories. But yeah, it's exactly based on him.
Down the front here, just across here. Any from online? Dan, can you put them all together for?
Thanks very much. My question is for Dr. Sarah Hartman. As I understand it, the CSIRO already had a simulation model. So could your agronomist assistant have been developed without artificial intelligence? Could you explain to us what the artificial intelligence brings that you couldn't have done without it, if anything? Thanks.
Yeah, well done there. So you picked up on a very small nuance. So we're using AI to model a model. And you might go, huh? Why would we do that? So the CSIRO has put a lot of effort over, I think since the 1990s, to develop the original agricultural production system simulator, which is what we model. Now, the next question becomes, in the current era, if we wanted to unlock certain insights from that, integrate real-time data from our sensors, and kind of explore things that the original model wasn't designed to do. So let's say in our stakeholder engagement and feedback, we get really important questions that original model isn't designed to do. And perhaps that's because, you know, with AI, we have different capabilities coming to the market. So every AI could be designed to do a different thing. You have for example, your ChatGPT, which really focuses on generative AI text content, or you could have an image generation. But there's also a lot of value in that AI model for prediction and also just for data integration. So in summary, it's really important that we continue to develop the original model, the agricultural production system simulator. There's a lot that it does that the AI isn't designed for, but the reverse is also true. There's a lot that the AI is going to be designed for that we wouldn't see necessarily in that original model. Yeah, great question, thanks.
Thank you.
Edo and Sarah, thank you for your presentations. They complemented each other really well. Thoroughly enjoyed it. Got a question from Catherine in our online audience. What are some ethical or practical challenges you've encountered when deploying AI within diverse agricultural environments?
I might jump into that one first. So I talked a lot tonight about satellites, and I tried to give you that number of satellites are kind of in our sky everywhere, and they're collecting all types of information. I talked about red, green, blue imagery, so that's what our eyes can see. It's also collecting a lot of information. A really important question that comes up, and I think satellites are a great example, is around data privacy. And so we kind of see this across the agricultural landscape as our data becomes hyper-local. How is that data being shared? In the case of our satellites, those are collecting images from the sky. What that means is it doesn't necessarily have the consent of the individual and of that individual farm. This is an ongoing kind of ethical question that has to be navigated, and especially, for example, if you're working in situations of times of war or other aspects where there really is this very clear question around ethics.
Sigfredo?
Just briefly, so the data, in the sense of early applications of AI, we always were confronted with agronomists, agricultural practitioners and owners, that the main question was, okay, you put the sensors in my farm, you acquire the data, do the AI models, who owns the data? And my neighbor is my competitor, so he's going to be benefited. And that was the main question for 20 years. Even before AI, it was digital agriculture, sensor technology. Even Telstra, they had a program of AI, this was 10 years ago, and they were offering putting sensors in farms and stuff like that for free. And then you pay like your phone, and then you get the benefit of the data. But they were collecting data, and they were making the models, and then the growers, they, rightly so, they were saying, who owns the data, what's going to happen, so they're going to be benefited and stuff like that. So I talk about that in my chapter. I'm not selling my book, but I talk about that, and then I proposed to use data as a currency and using blockchain for like a ledger or transparency. So who used the data, at what extent, and what kind of application they're doing. So it's all transparent. And the other thing is I apply also the game theory that trying to say to the growers, if everybody is using it, it's lifting the whole flow. It's not just benefiting one grower. It benefits like an industry and small growers as well. Sorry, and the second part, if I have time. So there is what Sarah touched, is the emerging patterns in AI, which is really interesting. So you feed the models and then with data, but then they come up with really emerging patterns, which is called, which is can be briefly summarized into the move 37 from AlphaGo. I don't know if you know that story. The AlphaGo that won the champion, the South Korean champion Lee Sobol in 2016. And basically the move 37 was something that it was like unknown. It was like a move that everybody went, even the champion were like, what is this? And he went to smoke a cigarette because he was like, and actually lost. It was a move that nobody would do. I don't play Go. But that is an emerging pattern that actually machine learning and artificial intelligence can do in uncontrolled conditions. And the main thing that is proposed now is containment. Otherwise, it's going to be like unleashed. And we were discussing about the gorilla effect. I'm not going to explain it now, but yeah.
I think, Sarah, we'll end on Sarah. You want to wrap that up, Sarah?
Oh, yeah, no, actually, just something you said. So at the beginning of a month ago, I was in Vancouver for a conference, actually, someone mentioned in the last talk. So it's called the International Conference on Machine Learning. It's kind of where the brightest minds in the world gather to chat about cutting-edge machine learning. And there was this talk that really struck me, and I guess I want to leave it all with all of you. where the scientist was actually trying to understand how the computer sees the world. And kind of what you just brought up makes me think of that, because I think for us humans, we just assume that the computer thinks the way we do. But in this example, with the example of Go, the reality that we see, that we touch, that we smell, that we feel, unless we build that into our AI systems, and even if we build it into our AI systems, unless we do extensive testing, we don't necessarily know that AI understands the world the way we do. So I've said it before, but this really means that the human part of interacting with the AI is so incredibly important. Centering us in this narrative and always going back to human judgment. So don't assume the AI thinks the way you do and sees the world the way you do.
I think it's a wonderful place to end. Thank you both so much for sharing your expertise. It's just an amuse-bouche, a wasabi pea on a platter going past, for these wonderful speakers. And I know you're always left wanting more, and that's exactly as it should be, because you're going to get more. It's so wonderful to have you here tonight. And thanks to our conveners of this lecture series as well, Professor Bob Graham, who's not with us tonight, but Professor Ian Chubb here, Fellow of the Australian Academy of Science. Our next one is on Tuesday the 14th of October. And just as Sigfredo, you were saying about wanting to work in offence rather than defence, it is on AI and safety and how we're working there, all the ethics associated. And if you think AI doesn't respond the way we should, how do we put all of that into context? So it continues. I think we could go on for the next couple of years, every week, and we'd still be learning. So enjoy your Science Week. Thanks to, as well, someone who, very important for bringing it to us, is our sponsors, Pawsey and Digital Science. But most of all, thank you to you for turning out on a wintry night in Canberra and online, for coming out and learning mind-blowing, expanding stuff. But our two wonderful speakers, thank you.